Hi everyone, today we're going to study divergence of vector field. Let a vector field V equals V sub x I plus V sub y j plus V sub z k. The divergence of V is defined as div V equals gradient dot V. And we have this formula, partial derivative of v sub x with respect to x plus partial derivative of v sub y with respect to y plus partial derivative of v sub z with respect to z. Note that the process of finding the divergence is always performed on a vector field, and the result is always a scalar field. Example 1. If v equals xyi plus 3xy square j plus xz cube k, find divergence of v. Take note that this is the form of the vector field. V equals v sub xi plus v sub yj plus v sub z k. This is our formula for divergence of v. Step 1. List down v sub x, v sub y, and v sub z. So the v sub x is equal to the coefficient of I, that is xy. V sub y is equal to coefficient of j, and that is 3xy squared. Then v sub z, coefficient of k. We write here xz cubed. Step 2. Evaluate the partial derivatives respectively. Let's begin with the partial derivative of v sub x with respect to x, that is equal to y. Then partial derivative of v sub y with respect to y, and that is equal to 6xy. Then partial derivative of v sub z with respect to z, and we have this 3xz squared. Step 3. Substitute the values. So divergence of v equals y plus 6xy plus 3xz squared. This is the final answer. Let's define solenoidal vector field. A vector field V is said to be solenoidal if divergence of V is 0. Thus, div V equals gradient dot V. This is equal to 0. Now example 2. Show that the vector field V equals x times the quantity y minus z, then I, plus y times the quantity z minus x, then j, plus z times the quantity x minus y, then k, is solenoidal. So what we're going to do here is to show that the grad dot v equals 0, which means we're going to show that the divergence of v, and is equal to this formula with partial derivatives, is equal to 0. So step 1, we list down v sub x, v sub y, and v sub z. We started with v sub x, v sub y, the v sub z. Step 2, let us evaluate the corresponding partial derivatives. Let's begin with the partial derivative of v sub x with respect to x, that is equal to y minus z. Then, partial derivative of v sub y with respect to y, it is equal to z minus x. Then partial derivative of v sub z with respect to z, which is equal to x minus y. Step 3, let us substitute the values. So the div v is equal to y minus z plus the quantity z minus x plus the quantity x minus y. If we remove the grouping symbol and combine similar terms, the y here minus y will be 0. Negative z plus z is 0. Negative x plus x is 0, which means divergence of v equals 0. And we write, since div of v equals 0, the vector field is solenoidal. Remember, if empty set is a scalar field, then gradient dot grad of empty set equals 0. Or we write gradient square of empty set equals 0. Today, we're going to study curl of vector field. Let v equals v sub xi plus v sub y j plus v sub z k be a vector field. Then curl of v is defined as curl v, and the formula is gradient cross product v. And this is equal to, the formula for the gradient is partial derivative with respect to x, comma, partial derivative with respect to y, comma, partial derivative with respect to z. Cross product, the v, and that is v sub x, comma, v sub y, comma, v sub z. And we can evaluate this using the 3 by 3 matrix. The first row are the elements I, j, k. The second row are the partial derivatives with respect to the gradient. The third row are the elements of the v, namely v sub x, v sub y, and v sub z. By the idea of determinants, the computation now for the curl v is equal to this big formula. Note that the curl operation is only performed on a vector field, and the result is another vector field. Example 1, if v equals xyi plus yzj plus xzk, find gradient times v. Note that the vector field form v equals v sub xi plus v sub yj plus v sub zk. Also, the gradient times v means curl of v. Now let us write the formula of the curl of v. This is with respect to the 3 by 3 matrix. Now let us substitute the elements on the third row, which means the v sub x is the coefficient of y. So we write here xy. The v sub y is the coefficient of the j. So we write here yz. The v sub z is the coefficient of the component k. So we write here xz. Now, by principle of determinants, it becomes like this. Let's begin with the component I, which means we write here the element I and then the partial derivative of the function xz with respect to y minus partial derivative of the function yz with respect to z. Then minus the component j, we copy it here. Then partial derivative of xz with respect to x minus partial derivative of xy with respect to z plus component k is here, then partial derivative of yz with respect to x minus partial derivative of xy with respect to y. Simplifying now, the partial derivative of xz with respect to y is 0. Xz here is considered to be constant. Minus partial derivative of yz with respect to z is y. Then we copy the component I. Minus partial derivative of xz with respect to x is z. Minus partial derivative of xy with respect to z is 0. Then the j is here. Plus partial derivative of yz with respect to x is 0. Minus partial derivative of xy with respect to y is x. Then we copy component k. Simplifying this now, we have this negative yi minus zj minus xk. This is the final answer. Now let us define irrotational vector field. A vector field, capital F, is said to be irrotational if gradient times capital F equals 0. Example 2, show that the vector field capital F equals the quantity z cosine x plus sine y times I plus the quantity x cosine y plus sine z times j plus the quantity y cosine z plus sine x times k is irrotational. For our solution, let us show that the gradient times capital F equals 0, so that this vector is irrotational. So let us write the formula for the curl of V. And we have here now the 3 by 3 matrix. The first row are the components I, j, k. The second row, the partial derivatives with respect to the gradient. The third row are the components of capital F, that is v sub x, v sub y, v sub z. Substituting the values in the third row, we have like this. The v sub x is the coefficient of component I, and we have in here. V sub y is the coefficient of component j. V sub z is the coefficient of the component k. Computing for determinants now, we have like this. We start with component I, and we take the partial derivative of this function with respect to y. And the answer is cosine z minus partial derivative of this function with respect to z minus now component j. We copy the j here, then we take the partial derivative of this function with respect to x, and we write here cosine x minus partial derivative of this function with respect to z, and the answer is cosine x plus, now for component k, we copy it here, then multiplied first by the partial derivative of this function with respect to x, and we have this cosine y minus partial derivative of this function with respect to y, and we write here cosine y. Now, if we're going to simplify this, we will find out the answer is 0. Now we write, since gradient times f equals 0, or we say that the curl of v equals 0, Therefore, the vector field F is irrotational. Note that if empty set is an arbitrary differentiable scalar field, then gradient cross product of the quantity gradient of empty set is equal to 0. I hope you learned something from this video. See you again next time.